using molar and formula mass in calculations. So, how do you go about doing calculations, converting between moles and grams and atoms and so on? So we'll just begin. So how many moles are in 62.5 grams of helium? Well, you need to know the tools. So to go between a mass in grams to moles, the tool that allows you to go back and forth is the molar mass. Because it's given in grams per mole, or a formula mass to be precise for an ionic compound. That is the tool. So if you look up the molar mass of helium from the periodic table, you see that 1 mole of helium weighs 4.0026 grams. That's from the periodic table that you're given on exams. That's how much 1 mole of helium weighs. Recall from Chapter 1, Dimensional Analysis, that when you get an equality, like so, it can only be arranged in 2 ways, and which one you choose is dependent upon the unit. 1 mole of helium or is 1 mole. Those are your 2 options. So, which one you choose will become apparent if you write down the units in the question. So if we go back, so the question is asking for moles of helium. And we're given 62.5 grams of helium. So the conversion factor that we use has to be the one that will cancel with grams of helium. So grams of helium and this conversion factor is in the denominator, our initial starting quantity, the numerator, by definition, nothing underneath, just 1 unit. We will use this conversion factor in the calculation. One mole of helium weighs 4.0026 grams. If we do that math, you should get 15.614 grams of helium. However, we have to use sig figs, our sig fig rules. We did division, 3 sig figs, fewest number of significant figures. We have to round this to 3 sig figs. So 15.6, I wrote grams, sorry, moles of helium. The next calculation, what is the mass of 1 million atoms of iron? Okay, to go from atoms, or just particles in general, or atoms, or just say molecules, to moles, the conversion factor you use is Avogadro's number. In some way. So 1 mole is equal to Avogadro's number in particles, atoms, molecules, just context specific. And again, you can write this in only 2 ways as a conversion factor, similar to above. So the question is asking for a mass. Okay, so that means we write that down as our target. So a mass of iron. Grams. That's what the question is asking for. And we know we have 1 million iron atoms. So 1 million is 1 times 10 to the 6. Remember, mega is the prefix multiplier for million. Okay. So iron atoms. Okay, we get the units to cancel. So we've got Avogadro's number, okay, is an atoms or particles number. That will go on the bottom. Okay, there's Avogadro's number of iron atoms in 1 mole. Iron atoms cancel. If the calculation were to stop here, we would have moles of iron. Okay. But again, the question is asking for mass. Okay. So we're not finished yet. And then, so we need the molar mass of iron from the periodic table to continue. One mole of iron weighs 845 grams. Straight from the periodic table. So to get units to cancel, moles of iron in the numerator here, that means that mole of iron for our molar mass will have to go in the denominator to get the units to cancel properly. Pause, sorry for that jar, pause to give myself some more room. So the next conversion factor that has to be used, it's the molar mass. Moles of iron, we need to go on the bottom to cancel with moles of iron in the top in the previous conversion factor. 1 mole of iron weighs 55.845 grams. Moles of iron cancel. We're left in a unit of mass. Mass of iron. That's what the question originally asked us to solve for. Now we can solve. And if you do that math, should get 9 0.27 times 10 to the negative 17 grams of iron. Now sig figs here, 1 million, we just have one significant figure, technically speaking, so this would round to 9 times 10 to the negative 17 grams of iron if you're going to be particular about significant figures. Using molar and formula mass in calculations continued. This example is for a formula mass. So lead 4 oxide, review your nomenclature rules back in chapter 2, is an ionic compound. And ionic compounds exist as formula units. Okay, so how you calculate a formula mass is the same as calculating a molar mass. However, it's important to point out that ionic compounds exist as formula masses. And again, as a reminder, a formula mass for an ionic compound is an empirical formula. It's just a reminder. But how you calculate the formula mass, the molar mass for lead 4 oxide, is you add them up. You look up the values for the elements in the periodic table. 1 mole of lead weighs 207.2 grams, and 1 mole of oxygen weighs 15.999 grams. So we have PbO2. You have to multiply the molar mass of oxygen times 2 because you have 2 of them, and we get 1 mole of PbO2 weighs 239.2 grams. Okay, if you go through and do your sig fig rules and calculations, you'll see that that's the correct number to report. So that's the formula mass, the molar mass, for PbO2. So conversions, going from grams to moles. The question is asking for how many moles. Okay. From the previous slide, we know that the tool that allows us to go from grams to moles sorry about that, background noise. The tool that we use to go from grams to moles is the molar mass, which we've just calculated. Okay. So we've got 50 grams PbO2. Get units to cancel. Grams in the numerator. We need to put grams here in the denominator for units to cancel. So 239.2 grams lead, or 1 mole. The question asks us for moles. We're in units of moles. Be able to do the calculation now. Grams of lead cancel. If I do my calculation correctly, I get 0.209 moles of lead-4 oxide. PbO2. 3 sig figs, 3 sig figs. The next question. How many atoms are in 50 grams of lead oxide, lead-4 oxide? Okay, so the question has changed. So atoms. So this question's a little trickier than first appearance. We know we're going to atoms in PbO2. Well, PbO2 is a formula unit for an ionic compound. This formula unit, one formula unit, contains 3 atoms, or ions. 1 lead cation and 2 oxygen anions. So we will need that. But just to point that out, the question's asking for atoms, not formula units. Borrowing from above, 50 grams of PbO2. The first step is identical. 1 mole of PbO2 weighs 239.2 grams. We also know that 1 mole of anything is Avogadro's number. It's a counting unit. 6.022 times 10 to the 23rd. Formula units. Formula units. If I were to stop the calculation there, the answer would be incorrect, because at this moment you would be in formula units of lead oxide. Continuing on, that initial bit of information, the question is asking for atoms. There are 3 atoms in 1, or ions to be precise, in 1 formula unit of lead-4 oxide. Units cancel. Correct there. 2. Moles cancel, formula units cancel, left in atoms for PbO2. If I do my math correctly, I get 3.78 times 10 to the 23rd atoms in 50 grams of PbO2.